And welcome back to another episode of Calculus Basics. And today we're going to cover U-Substitution. So here are the basic rules of U-Substitution. The first rule is you're going to want to look at your integral, and most of the time it's either going to be a division problem when the integral is going to be, the function of the integral is going to be a division problem, or a multiplication. So usually one term will be the derivative of another. For example, if you have x and then if you have 2x and then let's say you had x squared will, you're going to want to make your u, and then the derivative of that will be 2x, so that will be canceled out within the equation, within the integral. So as I said, you're going to want to take the derivative on both sides, sub in that derivative back into it, and sub in your u value. So that'll get rid of the dx value. And then you're going to take the integral in terms of x, and then change your values, change your bounds, if you're going to leave it as u, or leave your old values and then sub your original u value back into the integrated function. Alright, enough jibber jabber, let's get started. Alright, so as I said before, you're going to want to choose a function of x that will be the derivative of the other one. Well, find one of them that has the derivative within the function and make that one your u value. Well, as you know, the derivative of sine of x is cosine, but there's going to be a problem if we were to choose that. So I'm going to go ahead and choose cosine of x. So we're going to make it cosine of x, correct? And then the derivative of both sides, du, equals negative sine of x, and then dx. And I know many of you are wondering, oh no, but there's a negative, and there's no negative within this one. No worries, all we're going to do is divide by negative 1, divide by negative 1. So negative du is equal to sine of x. Bingo, sine of x. So, bring that negative outside. Your u is cosine, so that's u cubed, and then du. Awesome, everything is no longer in terms of x, and there we go. So, as you know from my previous videos, to take the integral, you're going to want to add 1 to the exponent, divide by that number, bring that negative outside still, and then we'll go ahead and change it back to u, because we already took the integral. So our u, once again, is cosine of x. So that's cosine to the 4th power of x divided by 4. And that negative stays the same. And then all we have to do is plus c. Now I will be making another video where we would change the bounds, or do this and then plug in the values for the integral, but that's in another video. Alright, so let's go to a different problem that doesn't have cosine or sine. Now you notice how if I was to make 4 minus x squared the u value, the derivative will be negative 2x. So that's your clue. So u is equal to 4 minus x squared. Take the derivative of both sides. Du is equal to negative 2x. Bingo, look at that. Oh, gotta remember your dx if you want to be formal. So negative 2x dx, that takes control of that. So that's a square root of u. The integral of square root of u, and then we don't need that negative 2x anymore. Negative 2x dx, because that'll turn into du, as I did right here. So, as you know, the square root is anything to the half power. So the integral would be u to the 1/2 plus 2 over 2 and u, and I'm pretty sure you know how to add fractions by now, so that's 3 halves divided by 3 halves. Now, I know many of you are wondering, how do I do this? How do I do this if there's 3 halves? No worries, just multiply it by the reciprocal on both sides, on the top and bottom. So that's 2 over 3 u, 3 halves, divided by 3 halves by 2 over 3, which this cancels out. So our integral, or final answer, would be 2/3 u to the 3 halves. Now, all we gotta do is just sub in for u, and remember our u was 4 minus x squared, so 4 minus x squared all to the power of 3 over 2. Alright, well, there you go. Thank you guys for watching. Have a nice day.